Today I'll be teaching you about pseudocode. Pseudocode is one of those things that no one really likes to do. It's tedious, annoying, and it makes you kind of question why write code out by hand in a subject like computing. But today I'll be teaching you why we have pseudocode, how to write pseudocode as per H2 computing standards, and how to do it well. So the first thing that you have to take note of is pseudocode exists so that programmers can exchange ideas. A lot of the time, certain programming languages have concepts that are strictly specific to that language. For example, if a Python programmer wanted to explain the concept of a for loop to a C++ programmer, he might use something like range. While it does make sense to use that in Python, people who don't use that language might not actually understand that. So pseudocode is supposed to be kind of a common ground that all programmers can use, a common standard that they can share, so that ideas can be understood no matter what programming language it was supposed to be implemented in the first place. So without further ado, let's get right into it. Hey, so when we were doing A-levels, as in my batch, we used this document which you can find at this link over here. This might change by the time you take A-levels. I think it's best that you go clarify with your teacher which document has the correct standards for your exam, but it's probably going to be this or something along the lines of this. Without further ado, comments are a vital part of most programming languages. In C++, you would use a // as shown here, for example, and in Python you use a hashtag. In every language it's kind of different. HTML looks scary and some other languages don't, but in pseudocode you'll be following the // notation for comments. You put // and everything else for the rest of the line is just comment. Okay, moving on to data types. So the data types that we have in pseudocode are more or less the same compared to most programming languages. Integers are the same, characters and strings are the same. However, do note that in characters they use a single inverted comma, and for strings they use double, even though some languages like Python are a bit more flexible with it. Booleans are not true, false, 1 and 0, they're just true and false in all caps. And dates use DD, MM, YYYY notation. Interestingly, floats are now called reals, and reals just talk about any value that has a decimal point. In this case, you would need minimally one number before and one number after your decimal dot. And that is effectively what makes something a valid real. Moving on to identifiers, which again, it sounds fancy, but it's just your variable names and your function names. So do not start with a number, very clear. I mean, Python does not allow this. A lot of programming languages take deep offense to this, and one more thing you have to note is that it's case insensitive. So if we, for example, had my number, we are not allowed to create a different variable called my number or my number. Again, if you're listening to this on audio only, it doesn't make any sense, just look at your screen. Let's move on to declarations. So declarations are effectively how you would give a certain variable a certain amount. So in this case, you would declare, then the variable name, then you put a colon there, and then what type it is. Remember, this doesn't assign its value. We will go through how you assign a value to it later on, but this just tells you, hey, there is a variable that you need to make, an integer variable called counter. Well, this is for variables. For constants, it's a bit different. Since constants don't actually change, you just need to straight up give it its value. So in this case, constant pi equals to 3.1415 is perfectly acceptable to use. The reason why we don't use this for variables is because when you want to move on to assignments, you don't use an equal sign, you use an arrow. And this is because you're kind of taking the value of it and putting it inside of the variable that you're using. In this case, since value has the ability to change, you can't use an equal sign in this. Equal signs are kind of what you would use for comparison in this case. So you know how in Python you would use equals equals? In this case, just use equals. And wherever you would want to use equals, just use an arrow. Great, so now let's look at arrays. Arrays, as you know, are just tables, lists, whatever you want to call them. In this case, it's very similar to how you deal with variables, but there's a small thing that you need to take note of. Again, the architecture is the same. Declare whatever name you want, and then the colon, and then what type it is. But in this case, you need to say array is your type, and then within the square brackets, you need to give your dimensions. So this means you start at row 1 and you end with row 3. And again, you start with column 1 and end with column 3, just like how a noughts and crosses board will look like. For those of you not in the country that uses this word, it's tic-tac-toe. So then you have characters. Characters basically denote what each of these individual cells will be made of. So your array does not necessarily have to be made of numbers. It can be strings, it can be characters, it can be whatever you'd like it to be. You just need to specify of character or of integer at the end. And again, if you would like to assign a certain value to one of these, you would have to use noughts and crosses, 2, 3, and then put an arrow and then X. So it's basically like how you would do it with a variable, except you assign it to specifically that coordinate. And again, if you would like to do this to multiple, you will have to use a loop. You are not allowed to just say for all values in column 2. You're not allowed to say that. You need to use a loop. Don't like it? Blame Cambridge. Okay, let's move on to input and output. Input and output are really simple. It's input, whatever variable, and output, whatever variable. Again, streamlined, very simple. If you can't get this, rethink your life decisions. Next up, we have arithmetics. So for arithmetics, your same plus, minus, times, and divide all are the same as you would implement it in Python. Moving on, you have your divide. This divide isn't your regular divide, it's for finding the quotient similar to how you would in floor division. Then we have modulo. Modulo is that one annoying function you were taught and kind of don't really know how to use. For that, you would be using MOD. Beyond that, we have relational. In relational, you can think about and or not, your basic gates, and from there you can construct everything else. And after that, you have your equals to, is not equals to, etc. But for not equals to is this symbol over here. For greater than or equals to, greater than, lesser than or equals to, or lesser than, all of the same symbols apply. Great, now let's move on to if. So for if, it's very similar to how you would implement it in Python, except now there's a then instead of a colon, and at the very end you have an end if, so it doesn't just leave the indentation hanging. This is a simple structure to how you would implement it. You might be wondering, what about elif? Elif doesn't exist. If you want to implement something like elif, you need to put the whole thing inside of if, which means stacking an if inside of an if, inside of an if, and you keep going like that until your code works. I don't like it, you don't like it, same routine, blame Cambridge. Great, now we move on to case. So case is a very interesting one. Some languages use this religiously and some don't have it at all. But a case, you can think of it as a bunch of if statements kind of mashed together. So in this very simple example, we have input move, and case of move effectively says, depending on what the value of move is, let's do different things. If it's a W, do this. If it's an S, do this. You can kind of construct the same thing using a bunch of if statements where you say, if move equal to W, if move equal to S. This just saves you a lot of time and effort that you can spend studying other parts of computing. As for 12, 13, and 14, we can kind of tackle them in one shot. For loops. For loops are very similar to how you would implement them in Python. For your identifier like I, and then the arrow, and then what values you'd like it to do. It's very similar to your for I in range or for I in, except there's no in this case. You just replace this with I, and interestingly, value 1 to value 2. Do take note, value 1 to value 2 means it includes value 2. In Python, if you did for I in range 9, it will only go until 8. But in this case, value 1 to value 2 means value 1 all the way to value 2, everything included, all inclusive. Afterwards, you have your statements, and at the end you have next identifier, which kind of tells you I++. In most languages, this is explicitly stated, like for in I equals 0, I is less than n, I++, like in C++, but in Python they don't explicitly state it. In this case, you have to explicitly state it. Then we have repeat until. Repeat until is kind of similar to while. In some languages, it's considered do while, but it's a bit different. So in this case, it repeats a statement until a condition is met, which means the first time this is run, the statement will execute without even checking the condition. Then it checks the condition, and the second run of the statement depends on whether the condition is met. So it does first and thinks later, opposite to a while loop, where it thinks first and depending on the condition, it does later. Okay, now let's look at procedures. Procedures look scary, but they're not that bad. Not that bad in my opinion. So when you want to declare a procedure, you write procedure, and then the name of what you want it to be, like an identifier, and then whatever parameters you would like, and a colon followed by the type of the parameter. Then you have all of your statements inside, and then end procedure that you need to write at the very end. When you'd like to call your procedure, just put call, and then whatever the identifier is, followed by whatever the input is. So in this case, it's kind of similar to how you would implement it in most programming languages. For functions, it's going to be a bit different. So again, we have a similar kind of declaration. We have function, and then the name, and then after that your parameter and the type of the parameter. But you have to write returns integer, because every programmer needs to know what to expect out of a function. So after you write returns integer, you have all of your statements, and somewhere along the line, you have to put return and then the name for the integer that you are returning. Again, use end function, and when you would like to call it, you don't use call like you would for a procedure. Do note, the value that is returned out of this can directly be used. So if you want to output it, you can put output square 100. If you want to do math with it, you can directly do math with it. You need to note, however, that you can't use call, because you're not calling anything, you're straight up taking the value. Okay, this is where it gets to get kind of niche. A lot of schools won't really test this, but if your school is kind of crazy, then it's good to know. So firstly, we have file handling. In this case, you would use open file for read and open file for write, similar to how you use W and R when you're using your file in Python. Then you have while not EOF, which refers to the end of file, which is kind of how you read from it. You get to do read file, and then whatever's inside of this is the file that you're looking at, and you store it in line of text, which is a variable you defined at the very start. And then after that, you can kind of do write file, which then writes to the file, whatever file you specify, and again, whatever code there is over here, whatever written stuff there is over here. And at the very end, you have to close file. Again, very similar. You must close your file, if not, you might lose a mark for that. Okay, the very last part that we have to look at is kind of OOP. So you might notice I'm at 10.2, and that's because in 10.1, the code is kind of useless. The only thing that you need to know is that everything is assumed public unless otherwise stated, similar to how C++ functions in terms of structs. So now, let's look at this example. We have class pet, which is kind of how you would create your class, and then you private name string, which talks about your name attribute, and then after that, public procedure new. So this is the way that you can come up with a procedure while specifying what it is, what the security classification for it is, and what it does. So after that, we need to know inherits. Inherits is the only other thing we need to know. So when you have a subclass, right, you can use class cat inherits pet. It's because everything that's a cat is a pet, and in this case, the same OOP rules apply. Everything that the subclass has will not be accessible to the superclass, but everything that the superclass has will be accessible to the subclass. Again, your same OOP standards apply. At the very end, just remember to put end class and you're fine. Remember, there is no constructor. You don't actually need a constructor in this case. And then when you want to create your object, it's a very similar kind of way you would do it. You say whatever object name you want, and then after that new, and then class name and all these following parameters. So it'll be like my cat, and then you put new cat kitty shorthand. Very simple. This is going to be kind of a parallel to what you've already learned, so picking this up should not be too much of a problem. If your school tests this, I'm sorry, I don't know what you're gonna be in for the rest of your A-level journey, but well, let's just hope they don't. I hope you enjoyed today's video. See you in the next one.